Single-phase AC circuits. Phase 4, Part 4. RLC series circuits. Importance of topic. Remember, this topic is important for you to learn, and this is why. Not only because it is great to know the reasoning and theory behind what you do, but also because it is a large part of your T1 exam paper. Anything from 5 to 8 questions out of a total of 20 will be on RLC circuits, phasors, and power factors. Phasors and power factor to be covered in the next 2 videos. Know these RLC parallel and RLC series subjects well. Practice it and you will have over a quarter of the exam finished and with full marks easily. In this video, we will focus on RLC series circuits, combining knowledge from Video 1, Video 2, and Video 3 into this full version of RLC series exam grade question examples. In RLC series questions, Z becomes important again, or total impedance, as shown in previous videos of RLC and RC series. This is because all of the components, the resistor, inductor, and capacitor, are all in one branch of the circuit, one after the other. The exact opposite of parallel where the current can flow in different directions and paths. To summarize, in series circuits, the current is always the same as supply. The voltage changes across components due to volt drops. The exact opposite of parallel circuits. And impedance, or Z, is a formula we will use unlike parallel-only questions. This is what it looks like. Now on to RLC series example questions and solutions you will need for your exams. Here is what the RLC series circuit looks like. Draw it out in your exam, and put in the values given. This will give you a huge advantage over trying to picture it in your head. Also, if you make a mistake, the examiner can see that you understand the topic and can see where you went wrong and still award some marks. Don't forget to pause and rewind the video as you need, in order to follow along and practice the questions yourself. Time for RLC series questions. We will start with an easy one, which is when it asks to find the current. Question 1. Calculate the current flowing in the series circuit, when R equals 15 ohms, L equals 0.06 henries, and C equals 500 microfarads. This combination is supplied by 230 volts at 50 Hz. Remember the steps from the previous video? Just apply the steps needed to simplify. Step 1. Draw out the circuit diagram and enter the values from the question. Step 2. Write out all your formulas. Ohm's law triangles. Inductive reactance. Capacitive reactance. Total impedance. Total current. Volt drops across resistor. Volt drops across inductor. Volt drops across capacitor. Supply voltage. Step 3. As we need ohmic values for L and C, find XL and XC. As usual, use our formula for XL, which should look familiar by now, and the same for XC. XL equals 2 pi by 50 multiplied by 0.06. XL equals 18.84 ohms. XC equals 1 divided by 2 pi multiplied by 50 times 500 by 10 to the power of minus 6. XC equals 6.36 ohms. Step 4. Find the total impedance, or Z, of the circuit. Use this formula and plug in the numbers you found for XL and XC. Z equals the square root of 15 squared plus 18.84 minus 6.36 squared. Z equals 19.51 ohms. Step 5. Find I, using this formula from Ohm's law. I equals 230 divided by 19.51. I equals 11.78 amps. That would be full marks for this question. This will give you confidence to do more. To summarize, when asked to find the current in an RLC circuit, here are 5 steps. Step 1. Draw out the circuit. Step 2. Write out all your formulas. Step 3. Find XL and XC. Step 4. Find Z, total impedance. Step 5. Find I, or current. Let's do another easier question asking for current. This time, you should complete the question and I will give the answers for you on the following slide. Question 2. Find the current in this RLC series circuit, where R equals 5 ohms, L equals 0.2 henries, and C equals 150 microfarads. These are fed from an AC supply voltage of 230 volts at 50 Hz. Just apply the steps as shown in the previous question to break it down into smaller, easier parts. Have your formula book and calculator ready? You should pause the video now, and best of luck. Here are the answers to question 2. XL equals 62.83 ohms. XC equals 21.22 ohms. Z equals 41.9 ohms. I equals 5.48 amps. In these next RLC series questions, we will be asked to find the voltage across a component, or more likely, the supply voltage. They are the same, they just take a little longer. Just as finding the current in branches of the parallel circuits, in series, we just find the volt drops across each component. Follow the steps as before, and just add one more step. Let's practice some. Question 3. Calculate the supply voltage of the RLC series circuit when I equals 13 amps, R equals 10 ohms, L equals 0.01 henries, and C equals 200 microfarads. The supply voltage is supplied at 50 Hz. Now follow the steps. Step 1. As always, draw out the circuit. Put in the values. Step 2. Write out all your formulas. Ohm's law triangles. Inductive reactance. Capacitive reactance. Total impedance. Total current. Volt drops across resistor. Volt drops across inductor. Volt drops across capacitor. Supply voltage. Step 3. Find XL and XC. XL equals 2 pi by 50 multiplied by 0.01. XL equals 3.14 ohms. XC equals 1 divided by 2 pi multiplied by 50 times 200 by 10 to the power of minus 6. XC equals 15.91 ohms. Step 4. Find the total impedance, or Z. We don't need this value in this particular question, but it is good practice to find it anyway. Z equals the square root of 10 squared plus 3.14 minus 15.91 squared. Z equals 16.22 ohms. Step 5. In this step, we find the voltage across each component separately before we can get the supply voltage. Do each of the 3 out using Ohm's law. UR is equal to 13 times 10. UR equals 130 volts. UL is equal to 13 times 3.14. UL equals 40.82 volts. UC is equal to 13 times 15.91. UC equals 206.83 volts. Step 6. Find UT, or total voltage. With all of this information, we can now find the supply voltage using this formula. UT equals the square root of 130 squared plus 40.82 minus 206.83 squared. UT equals 210.8 volts. This is a full marks answer. Now as with question 2, this question is for you to try. Question 4. Find the supply voltage in the RLC series circuit when I equals 10 amps, R equals 10 ohms, L equals 0.1 henries, and C equals 100 microfarads. They are supplied by an unknown voltage at a frequency of 50 Hz. Just follow the steps as shown previously. Answers will be on the following slide. Pause now and best of luck. XL equals 31.42 ohms. XC equals 31.83 ohms. Z equals 10.01 ohms. UR equals 100 volts. UL equals 314.2 volts. UC equals 318.3 volts. UT equals 100.08 volts. Hopefully your answers match these. If not, try again. That concludes RLC series questions. This should be enough knowledge to almost cover the entire first quarter of the exam. There is a few more areas that we need to look at in the next 2 videos. Those are power factors, phasors, and resonant frequency questions explained and answered. Keep practicing these RLC series and RLC parallel questions in the meantime. Cheers, and see you on the next one.